Hallo, I'm going to go over examen VWO 2019, Tijdvak 2, period 2. First question, minimal length. We have a function given by this expression, and on that function there's a point P, and there's also a point A given by 7, 0. The length of AP depends on the position of P, of course, but point P is picked so that the length of AP is minimal. Well, what's our point P? If the x is lowercase p, then the y is just the function f evaluated at p. We know point A equals 7, 0. So that length of PA that's you just get from Pythagoras, and let's just put the length square, because if the length is minimum, the length square is also a minimum. So you get, I just take P minus A, so it's P minus 7 squared, and that whole thing P minus 3 squared plus 2, but then D square, that's basically P minus A. The factor, this is the length of the factor P minus A, or the length squared. Now this has to be minimal, so what you can do is just work this out, take the derivative. This is p squared, this is third degree and squared, so it's actually 6, so the derivative will be fifths. And given that they say that you have to give your answer in 2 decimals, that's actually immediately a hint you should use your calculator. And why don't use it now? Again, I will be using Wolfram alpha. I just ask it to look at that function. Okay. X minus 7 squared p times minus 3 power 2 plus 2, and this to the power 2. What did I do? I have confused this poor Wolfram alpha. I just have one variable x, and this here you see the form. So yes, it actually has a minimum at 3 point something. So this is the global minimum at x equals 3.25. And so it is at p equals to 3.25, and the value is 18.916. So that will be the value of L squared actually. They're asking the length. So let's just get that calculated here. 18.916. There we are. So the square root of this is 4.35. What did I say? 2 decimals, right? Okay, so this is then the answer. Question 2. We have a moving point P described by these equations, and we have point P on the x-axis, and it can be in 3 positions, 4 positions, 3 positions. But one of these is to the left of the y-axis, and calculate exactly what its x-coordinate is. Right, so we need to set y of t equals to 0. That means that the sine of 2t minus sine t is equal to 0. I write this as the 2 cosine t times sine t. And we can factorize sine of t. We get 2 cosine t minus 1 equal to 0. So sine t is 0, or cosine t is 1/2 in this interval here. So we have 0, pi, 2 pi. Obviously you guys have to be really familiar with these with the sign. So, well, it's here, here, and here. What about the cosine 1/2? Well, you can either use your knowledge of the unit circle, so where the cosine is the projection on the x-axis, so right in the middle. So that will be this angle, which is 60 degrees. Or, since pi is 180, this is pi over 3. And then it will also happen when you reflect it in the x-axis. And it's kind of minus 60, which is then 360 degrees, 300 degrees. And that's basically, so this is, what is it again? This will be also pi over 3 plus, so I get pi over 3 plus 270 here, which is No, not pi over 3. This is pi over 3, this is pi over 6, this is 30 degrees. Just as here, so we'll get pi over 6 plus 3 over 2 pi, which is 270, and that is pi over 6 plus 9 over 6 pi is 10 over 6 pi is 5 over 30 pi. Well, probably already need to know this, or you can also easily check this in your graphic calculator. As a matter of fact, you should probably plug in the original function and double check the answer. So what do we have again? A pi over 3 and 5 over 6 pi. Now we need to see what happens with x for these. Well, at 0 you get the cosine of 0 is 1, and the sine of 0 is 0, so you get 1. And actually, because of the factor 2 here, it's the same for pi and the same for 4 pi. So these all give x is equal to 1. And pi over 3 will give cosine 2 pi over 3. Basically you double this thing, so you end up here. So that is minus 1/2, and the sign will be plus 1/2 square root of 3. Sine again, remember you need to multiply by 2 here. So what you get is x is minus 1/2 plus 1/2 square root of 3. Now this is actually positive, so that's not the x of p. So let's see what happens for t is not 5 over 6, 5 over 3. I'm sorry. Okay. 5 over 3. Now I need to know what is the cosine of 10 over 3 pi. Well, 10 over 3 is 3 1/3. So I rotate 3 times pi, 1, 2, 3, and I add 1/3 of pi, So it's a little bit messy here. I end up here, and well, I have so this is my cosine here, and here's my sine. So they're both negative. This is negative 1/2, and the sine is negative 1/2 square root of 3. So x is equal to minus 1/2 minus 1/2 square root of 3. So yeah, so these 2 points here are basically minus 1/2 plus the square root of 3 or minus the square root of 3. Question 3. At times t and 0 and pi, we have a point P that's actually in the same location. It's given here by the dot. And also they give the velocity vectors of P at 0 and pi. And they want us to calculate algebraically the angle in degrees between these two vectors and 1 decimal. So for this, some basic knowledge, it's you have to know, and you can just state that. You don't have to prove it. It's one of the things listed in the requirements. That this is just given by the derivatives of the components. So like this. So you can see each is like the, well, velocity or speed is distance over time. So you get the derivative of x by t. So you can calculate that cosine. The derivative of a cosine is a minus sine, and with the chain rule then you get minus 2 sine of 2t. Again, this is error prone, do this carefully. Then the derivative of a sine is just a cosine, and I get a factor of 2 from the sine rule. So cosine 2t. And here I get the derivative again of a sine. So I get 2 cosine 2t. And here I get simply a cosine of t. Alright, so what is this factor at 0? It's minus 2 times the sine at 2t. Now that's 0. And the cosine of 2t is the cosine of 0 is 1. So minus 2. And here again we have 2 times the cosine at 0, so it's 2. And then minus the cosine at 0, so minus 1. So this is minus 2, 1. Well, what is it at pi? the sine of 2 pi is also 0, and this becomes the cosine of 4 pi, which is 1, so I get minus 2 here. Minus 2, 0, minus 2 times 1, and here I get a cosine of 4 pi, so I get a 2 times 1 minus the cosine at pi. The cosine at pi is also negative 1, not also, but it's negative 1, so I get plus 1 here. So I get minus 2 and 3. And that roughly makes sense if you look at the directions of these two factors here. And now I just need to use that the inner product, this was S before, so you have to notice inner product of two factors is related to the cosine between the two factors. So the cosine is just divide both sides by these norms here. So the cosine, if I call alpha the angle, is then the inner product. It's 4 plus 3, and the norm of this is 2 squared. You don't need to grab the sign here, it's just 2 squared plus 1 squared, and I need to take the square root. Here I have 2 squared plus 3 squared, which is 4 plus 9 is 13. So 7 divided by the square root of 5 times 13 is 50 plus 50 is the square root of 65. And then we just use our calculator, find out what alpha is. So that's 7 divided by 65 square root. And then I take the inverse cosine, and alpha is 29 and 1 decimal, 0.7. Question 4 is about a knikpunt, and that's a point like given here, where the function is continuous, but obviously the derivative is not, I forgot the English name now, but it's clear what is meant by it, and it's of course coming from this nasty absolute value. And working with this, you always have to split it in two scenarios, that this thing is equal to x minus 2 if x minus 2 is greater or equal to 0, and negative that one if x minus 2 is less than 0. So that's the next point is in A, and obviously it splits the graph in two parts because of this, and the tangent L is a tangent in the left part. So in this left part, we have x is smaller than 2. So which one do we use then? Well, this is x greater or equal to 2, and this is x is smaller than 2. So we just assume this, and then we okay, what we write is for x. We have that fx is simply minus x minus 2 times 1/2 x plus 2 plus 1. So let's work this out. I get minus 1/2 x squared, and then I pick up a 2x here. Why don't I just write it out? I get a minus 2x here, and from this term I get a plus 1/2 x. No, I get minus 2 times 1/2. So I get plus x, and a negative 2 times 2 is negative 4 with a minus sign. So it's this. Minus 1/2 x squared minus x plus 5 and now we have to evaluate this in this knikpunt, and we know that happens when x is equal to 2. So we get, and this function f, actually I probably should call this some other function like g, but well, we already stated that this is only true for f. So yeah, so you can strictly not substitute 2 then, but in the limit of this function going to 2. So we should, strictly speaking, put a limit here, but I think for this exam it's fine. You get minus 1/2 4 minus 2 plus 5, which is minus 2 minus 2 plus 5 is 1. There's something wrong. That it should have a negative slope. What did I do wrong? Oops. I'm supposed to calculate the derivative of this function. Guys, embarrassing. This is the function itself. Actually, it's still useful to have the function evaluated at 2. So I just calculate that f of 2 is equal to 1, right? That roughly makes sense. I need to calculate now the derivative of f. So f prime of x, strictly speaking, only defined here, is minus x minus 1. Okay, so f prime at 2 is negative 3. That makes more sense. And now the equation of the line L. So let's set up the general form. So like the slope-intercept form, but we know m is negative 3, and we want this point to be on the line, so we demand that 1 is negative 3 times 2 plus b, so b is equal to 6. And the line becomes minus 3x plus 6, which again roughly makes sense here, just as a double check. Question 5. Optimal cutting speed. They look at some drill machine that is making holes in some materials, and the lifetime of the drill or the drill head is dependent on the speed of the cutting speed they call it, which is the speed with which the outside of the drill cuts through the metal. And higher speed will means faster degradation or wear of this drill. Okay, that makes sense. And some smart guy, F.W. Taylor, came up with this relation with V is the cutting speed in meters per minute, and T is the lifetime, and M is a constant dependent on the drill material, the material with the drill is made. And C is a material dependent constant. Wow. Alright. And they say M and C can be determined experimentally. So, and they give two kind of values. So which means that, and these, what they're asking for is algebraically to get the values of M and C for this situation. But M has to be in 2 decimals and C as a whole number. Okay, why not? So I can hear you need to know some basic Dutch, I guess, to understand this. What exactly is what? So this 20 here is the speed. So is this capital V. So you get 20, and then this capital T is the lifetime. So 20 times 116 to which power? To the power m, which is unknown, is equal to the other thing we want to know, namely capital C, the material dependent constant. And the other known is this 30 times 40 to the power m equals C. So 2 equations with 2 unknowns. Well, we just easily eliminate c by setting these two equal. So you get 20 times 116 to the power m is 30 times 40 to the power m. And let's bring these powers of m to the left, and we get 116 to the power m divided by 40 to the power m is 30 divided by 20. And what is 116 divided by 40 is 2.9. So 2.9 to the power of m. So we use here that a to the power n divided by b to the power n is a divided by b to the power n. Some basic skills. And it's 1.5. So now we see the base is 2.9. So what you need to know is the equation for change. Of course, we want to take the logarithm with base 2.9 to isolate m. So let's actually do that. You get, so I'll write it out. So 2.9 log 2.9 is a logarithm of base 2.9, 1.5. Now this is m, so this is m here. So we have to calculate this. I think so. For this, you need to know how to change the base of logarithms. That's also a basic equation that has to be known. So under the exam programma, you can see this. So we have, now we just go over to an arbitrary logarithm, maybe the base 10, since then we can put it in the calculator, or this is a natural logarithm. So we get, this is log 1.5 divided by log 2.9, and this here, this you don't need to prove this. This is basic knowledge. I think you can prove that by setting x is some base to the power x, and then take the logarithm on both sides with another base. If you work out, you can find this easily if you forget this exactly. Okay, so then we just plug that into the calculator. You can, yeah, it's a 1.5. Is that all? Or 1.5 log divided by 2.9 log is 0.38. Let's keep 3 decimals here. And going back to the question. So I found M now. And now we find C. Okay, so we I just opened Wolfram Alpha. So we get 20 times 116 to the power of 0.381. So we get C is 122 if I approximate it to a whole number. Question 6. In the factory we have a drilling machine that for 24 hours is drilling the same kind of holes. Oh my god, this is a messy question. It's important that you optimize the speed of the drill, but if you make the speed too high, then you have to replace the drill more often, and you want to optimize the number of holes per 24 hours, which they call A, and they do the following. So we want to express A in phi. Basically you want to get the best speed, phi, so you want to express A just in phi. Then the number of holes n in 1 minute is proportional to the speed. That makes sense. And then they give, by a certain speed you can get 6 holes per minute. And the equation above can be used to get the duration or the lifetime of the drill. And every time you need to replace the drill head, it will take 2 minutes. That means that the drill is not always working, but just a part of the time, d. And d is t divided by t plus 2. It's kind of a duty cycle. That's probably why they call it d. And then they give an equation, which, so you don't need to derive this, they give this, but I guess that makes sense if there I guess there are 1440 minutes in 24 hours, and is the number of holes per minute, and d is kind of this duty cycle. So I give this, and then they say combining this all you get this equation for A in terms of phi. Okay. Well, this question is a little bit messy. I don't think it's really difficult from the math perspective, but there's a lot of language in this. Well, let's try. Let's try what is exactly known here. Well, they already give an expression for A, which is this, but it's not expressed in phi. We want to express it in the speed of the drill. So let's see if we can find this capital N and D. Well, A will tell you what N is in terms of the speed. That's good. It's directly proportional. It's a direct proportion. So let's first work out N. So they're saying N is some K times V. And then they say that in particular for V is 20, you have 6. So it means that K is 6 divided by 20 is 3/10. So I have my N. Now I just need to find my D. And D is T divided by T plus 2. And what is T? Well, we have to figure that out from some properties of this particular drilling process given here. Namely, V times T to the power 0.25 is 150. So, which means T is 150. T to that power is 150 divided by V. And we can, of course you can recognize this is 1/4. So it's the, so if we take both sides to the power of 4, this still has to be valid. So we find that T is 150 divided by our drill speed to the power of 4. Okay. So you can then just substitute this all, but there's only one term T here. Okay, so what we can do, since don't want to keep on writing this, what you can do here is to say D is 1 divided by 1 plus 2/T. And I just do that because I see what they're asking for. There's actually no need to do it otherwise. So let me then start writing out A with everything I know. It's 1440. What was N again? 3/10 times 1/1 plus 2/T. And if this is T, then 2/T is 2 times this with the numerator denominator flipped. Right, that's, I guess that's obvious. And again, I think these basic skill formulas I had just now, you can use these equations in specific skills. Okay, and Just check that. 1440 times 3 divided by 10. Yep. Oh, wait a minute. Oops. I substitute an escape fee, so I forgot my fee here. So I get 432 fee. Well, times 1 over. Yeah, I can get this from out of the parentheses. So I think it's pretty obvious that this is equal to this, which is what they were asking. Question 7. So now you can plot your A as function of phi, and they show that curve, and as you can see it has a maximum somewhere, so maximum output of your factory. And if you do too fast, you keep on replacing the drills, reducing output, but if too slow, you also get less output total. And find what is the optimal speed. So what we need to do is find the derivative of A as function of phi and see when it's 0. Okay, well, it's a little bit. So let's just first define these constants that are there. Because you have to take the derivative of this, and it's a quotient of functions. So A prime of phi is the denominator times the numerator, the derivative of the numerator. So we get B. So just to repeat this thing here. Times A, and then minus the derivative of the denominator, 4b phi to the power 3 times a phi. And this whole thing we need to divide by the denominator squared. Okay, not difficult, but definitely messy and error prone. Double check. 4b a phi. Okay. And then we can say that if this is 0, this is always positive. It could get 0 depending on b, but let's ignore that for now. For this a prime to be 0, definitely has to be true that the numerator has to be 0. So let's just there's actually a common factor a, so I can already pull that out, and I get 1 power 4 of v, and oh no, 2 actually, 2. Let's not do too many in one step. I just work this out. A, B, v to the power 4 plus a minus 4a b times v to the power 4. This has to be 0. And now I can just let's do it step by step. That's still the smallest chance on errors. It's ab v to the power 4 plus a has to be 0. And now I can write this as minus 3b so a is 0. Well, a was this which is not actually, it's not 0. So oh, actually I come to think of it, b is also positive, so this denominator here can never be 0, so I don't need to worry about that. Alright, so let's just say then that this means 3b v to the power 4 has to be equal to 1. So v to the power 4 has to be equal to 1 over 3b. And now we can, so actually it doesn't depend on a at all, which kind of makes sense because this is the kind of related to the number of minutes in a day. And it's 432, b is 2. Alright, so this is basically 1/3 times 150 to the power 4 divided by 2. Is 150 to the power 4 divided by 6. Okay. Well, what I can do then is I have this power 4. Let's just write it then as v to the power 4. Well, you can just calculate this and take the root. But when we try to be smart, which doesn't happen that often, I write this as the, actually it doesn't matter. So v is then 150 divided by this root. Oh, in 1 decimal. There's also negative roots, of course, but that doesn't make sense. You cannot have a negative speed. You might have complex roots as well. Let's just calculate this. 150 divided by 6 to the power 0.25. That's 95.8. And that is, what did they ask? In 1 decimal. So 95.8. What's the unit again? Meters per minute, which is the speed. So the unit of the speed. Question 8. We have a function given here and also a certain area defined, and they give some equation for the area here which we have to prove. Okay, that area A of P is the integral from P to pi minus P of 2 sine x. So that is 2 times the primitive is the cosine of x. But careful here with the minus sign. The derivative of the cosine is negative sign, so we have to compensate for that. Put a minus in front to get a plus sign here between pi minus P and P. And that is minus 2 cosine pi minus P. And then I need to subtract this thing, so that gives a plus sign, so I get plus 2 cosine of P. Almost there. Well, cosine pi minus P. Well, you can think of in this way. If we go to if we draw a unit circle, which I'm very bad in, then in particular on this writing pad. But let's say we take some angle and we add pi to it. Well, what happens to our cosines, or our sines incidentally? They will change sign. So we rotate by pi. So this basically is the cosine of pi minus P is equal to the cosine of minus p, and minus, oops, that was my main point just now, you pick up a minus sign, and the cosine function is symmetric, so this is cosine p. And the symmetry you can also see here. If I go to a negative angle, this projection on the x-axis keeps the same sign. So it's called a even function. So this then is 2 cosine p plus 2 cosine p is 4 cosine p, which we had to prove. You can also apply the equation for the equations given in this test, and just substitute pi and p. Then you can prove the same thing. There are actually two equations which are equivalent. Question 9. We intersect the graph f with these vertical lines, and these intersection points are P and Q. And this horizontal line divides the total area in two. And then you can define V and W. And then they say there's only one value of P for which these areas are the same. Calculate this value of P in 2 decimals. Okay. Well, we need to find out what V and W are and set them equal. So for V is this area between these lines. But actually, let's do it a bit different. We know this area here from the previous exercise. So we know that V is basically that area A given by the previous one, and minus W. And W is just a rectangle, which is easy to calculate. Well, what's the area of that rectangle? That is the length times the height. Well, the length is pi minus p minus p, right? That's this distance here. And you multiply by the height. What's the height? That's just the function evaluated at p, or pi minus p. What was it again? 2 sine x, so 2 sine p, and this is equal to pi minus 2p. 2 here, and the sine That's our W, and we want these to be equal. And AP is given by 4 cosine Okay. Okay, so in order for phi to be equal to W, so you get that AP minus W is equal to W, and this gives our equation AP is 2W. So we get the equation 4 cosine P is 2 times this thing here. So it's 4 times pi minus 2p sine p. 2. All right. Well, you could put this as one tangent by dividing by cosine p both sides. But that actually doesn't add a lot of information in terms of solving this. I think this is difficult to solve analytically, but anyway, the expectation was to do this numerically. And you can just define 2 functions and have them intersect. Or in Wolfram alpha, I would just let me cross out to 4. What I will do is I will study this function minus cosine and find out when this is equal to 0. So I don't know how to define. I don't know if there's a constant for pi, so I just use the arc cosine of 0 times 2 for pi minus 2p times the sine of p minus cosine. Let's study this. Okay, here it is. You see, it is we're interested in this from 0 to half pi. So you see here it is 0, and there's another point here where it's 0. So in that interval you have P is 0.405, and there's also P is 1.57. Well, this is probably half pi. There is actually one solution that can be found analytically. Let's see what happens if P is pi divided by 2. You get pi minus, so this is 0, and the cosine of pi divided by 2 is 0. Yeah, so this probably is pi divided by 2. But then, well, you can see this. These integrals are just 0 then, and as a matter of fact, that's even not included in the interval. So the final answer then is two decimals. P is 0.41. Question 10. A function f is given here. It has a horizontal asymptote and a vertical, which intersect at B, and A and C are the intersections with the horizontal asymptote. No, C is the intersection of the horizontal asymptote with the function f, and A is the intersection of the horizontal asymptote with the y-axis. Now prove that B is the middle of AC. Alright, what are the chances of that? We need to calculate this horizontal asymptote. So this is from the behavior if that x goes to x goes to minus infinity. Well, e to a large negative power will approach 0 very quickly. Same e to the power 2x I meant, and e to the power x as well. So, and compared to these constants here, you can ignore them. So you get 0 minus 1000 divided by 0 minus 10. So that is 100. So the asymptote is the line y is 100. Alright, let's first find and what's the, so this is the h, the horizontal asymptote. Let's find the vertical. Well, there's a vertical asymptote if this denominator reaches 0. So when does it happen? E to the power x equals 10. So take the logarithm on both sides with base e, and you get x is log 10. So we know A now. A is 0, 100. What did I just do? So here the x coordinate of B is log 10. Log 10, and the y coordinate is also 100, of course. And now we need to calculate c. So when is this function equal to 100? So we've got 2x minus 1000 e to the power x minus 10 equals 100. So we get e to the power 2x minus 1000 is 100 e to the power x minus 10. At e to the power 2x, bring this thing to the left. And actually we just work it out, plus 1000, 0. So these two drop, and I saw something like this before. What you do here is just, you can define e to the power x as a u, and then you get u squared plus 100u, but you don't really need to do that. You can just see that you can factorize e to the power x. So this to be 0. That means that e to the power x must be something wrong. What did I wanted to solve this to be 100 minus 1000 minus 10. Always check step by step. See how it's so easy to make mistakes. But in this case, fortunately, found it because it wouldn't have had solutions otherwise. So here this doesn't have any 0, so I just say e to the power x equals 100. Take the natural log on both sides, so I get x is the log of 100. Okay, and in order for b to be in the middle, we need to have bx is 1/2 ax plus cx. And just substitute it, and basically this is the question: is this true? Well, is log 10, is that equal to 1/2 ax is 0 and cx, what was it again, log 100? Well, yes. You can take the half inside, then becomes the square root. So, or you can multiply by 2 as well, and this becomes the log 100 then. But yeah, so log 10 is log 10. So yes, B is in the middle. Question 11, Wind aan Zee. This is about the direction of the wind. Again, a long story. But basically, you have the sea, the land, you have wind factor WZ, which is the result of the sea temperature. Then there's a WD factor, which is the wind due to the air pressure differential between high and low pressure. And WR is the resultant, so that's the sum of these two. And now they have a situation where the WC has a speed of 4 meters per second going inland, and WD has just the speed 6, no direction indicated, and the resultant wind T has to flows parallel to the coastline. So what do we have? This, let's say this is the coastline, sea, land, and we have a W factor WC, and we have WR, the resultant is this WC plus WD, but they're not telling us what the direction is of WD. So what does this exactly mean, adding the factor to WC? Well, it means, let's put it in red, that you put the tail of the factor to the head of WC and then have it point in a certain direction, like this. This could be WD. But we only know the length. This could also be in this direction. So basically, let's see, what are they actually asking? There are two possibilities for WD. Well, so if the resultant is along this coastline, I guess there are two possibilities. Either up or down, as long as it's along the coastline. So Well, let's just see what all the possibilities are for WR, given that we know WZ. And this is 4 and 6, so all these factors that are possible form kind of will end up at a circle. So let's draw a circle, maybe a little bit smaller. With the center, no, has the with the center, the head of the WZ factor. So it's like this. And since we know that WR is either in this direction, so this is WR1 and this is WR2. We know that the factor WD must be this one or this one. So this is WD in case 1 and this is WD in case 2. And to calculate this, we just need to calculate the intersection of this circle with the coastline. And I think that's what Oh, now I didn't use the origin as the begin point of this vector. I just put it on the head of WZ. So, well, we then need to translate it. So this, something like this, would be WD, but also parallel. Also, this would be WD. And I think this is what they were asking. And just try to explain a little bit what I put in words, that about all the possible resultant factors are on this circle, but it's also given that they are parallel to the coastline, so that basically gives these two options. Question 12. On a certain place along the coast, namely point O, the coastline makes an angle 30 degrees with north, and the wind is in this direction of the southwest here, 5 meters per second, and Z has a speed of 3 meters per second, again perpendicular on the coastline. And then figure 2's are the line north-south, east-west, the axis of the axis. So this is our axis. The line through the origin on which WD is this dashed line, okay, 45 degrees, yes, because it's blowing in the southwest. Then the question is, calculate algebraically the speed of the resulting wind and give your answer in 1 decimal. So we need to find the resulting wind in 1 decimal. The resulting wind is the sum of these two factors that are given. So we just find what these factors are. So we decompose these in x and y, and this angle here is the same as this angle because this two sides of this angle are perpendicular to two sides of this other angle. So this will be minus 3 times the sine of 30. And this will be plus 3 cosine 30 degrees. And we can do the same for our WT. They're both negative. This is minus 5 sine 45. And this is minus 5 cosine 45. Okay, well, that's not so tough. So we get, well, actually, the sine of 30 degrees is 1/2. So you get minus 3/2, and 3 times 1/2 times the square root of 3. So 3/2 times the square root of 3. And I can just immediately add them plus, or minus actually, because they're negative. 45 is just 1/2 square root of 2. So I get 5/2 square root of 2 and minus 5/2 square root of 2. Does that make sense? So we have no, that doesn't make sense. I'm not sure what I was doing. The x coordinate is 3 times the cosine, and the cosine, I don't know how I did that. 3/2 square root of 3, and then this is minus 3/2. That's minus 3 times 1/2. And this should be correct. We need to find the speed, so that's then this ugly expression. Let's just put it in brackets for the square root. So, 3/2. I need to repeat that. Squared plus minus 3/2 is minus 5/2 square root of 2 squared, and then the square root of this. So I guess you could already put these components as numbers, but anyway, I already wrote it down, so I just want to type this in. Okay, a square root, and then something squared plus something squared. No, already wrong. Then say 1.5 times and another square root 3 minus 2.5 square root of 2.5 square root of 2 squared. Let me copy this. But replace this by minus 1.5. Okay. Then you get 5.1. And we had to give it in 1 decimal. So it's 5.1 and meter per second. Question 13 is about two logarithmic functions. We have a line y is q which intersects at a and b, and there's certain values of q for which a is to the left of b, and the length of AB is equal to 3. Calculate these values of q, give your answer in 2 decimals. So probably we need to use a calculator again. Alright, well, let's find a and b. So for a we have the log of square root of x equals to q. Now we take, we use, if a is equal to b, then certainly e to the power, not e to the power, well, any base to the power, but certainly 10 to the power a, also 10 to the power b, and vice versa. So I find that the square root of x is q, and x, no, not q, 10 to the power of q, which means that x is, if I square both sides, is 10 to the power 2q. Now we go to look at b, we get then log x times the square root of x minus 1 is q. Right. I bring the 1 to the right, and I do the similar thing here. I get x times the square root of x is equal to 10 to the power q plus 1. And I can take this, if I realize that this is x to the power 3 over 2, so I can isolate x if I take both to the power 2 over 3. So I get x equals 10 to the power 2/3 q plus 1. Now, in order for this distance to be, this length to be 3, well, that means now that that whole thing minus 10 to the power of q 2q is 3, and I don't see actually how that you can do much analytically here. Just as soon as you have an equation you need to solve, just put it in your calculator. So I fired it up. I get 10 to the power of 2 divided by 3 times x plus 1 minus 10 to the power of 2 times q minus 3 is 0. Doesn't matter, I can put 3 to the right as well. Well, we have to solve this. What are the 0 points of this function? Double check. No, I called it x. Okay, let's see. And again, I don't know how that. I don't have a graphic calculator. But here you see that function, and it actually has 2 0 points given here. So we use our graphic calculator and we get minus 0.21 or 0.344 for our, that's actually for our q. And was that what they were asking? Yes. And did they say anything about q? No, there doesn't seem to be any restriction q, so this should be the answer. And 2 decimals, so okay, so we have q this, or question 14, they say that these two graphs intersect at x equals to 10, and if we have a line x is p for p larger than 10, it will intersect in 2 points C and D, and though that p larger than 10, okay, the proportion between CD and CE depends on p. And we have this equation and we have to prove that. Okay, well, what's CD? That's G at P minus FP. What was it again? I get the log of P, square root of P minus 1 minus the log of square root of P. And CE is a little bit more simple. It's just the log of square root of P. Alright. Now let's first, because what we have to show is all the log of P itself. So let's all convert the arguments here to P. So CD is, this is P to the power 3 over 2. So we get 3 over 2 log P minus 1, and here I get minus 1/2 log P. And similarly for CE, I have 1/2 log P as well. And these two I can combine as this is 3 over 2 minus 1 over 2 is 1. Okay, starts to look like something minus 1. And now I think we found it. CD divided by CE is then log P minus 1 divided by 1/2 log P is 2 log P minus 2 divided by log P. When P increases, this fraction will have a limit. Calculate exactly this limit. Okay, well, CD divided by CE, or the limit of P goes to infinity. The limit of P goes infinity of P minus 2 divided by log P. And here what you do is just divide by log P. So you get 2 minus 2 divided by log P. Divided by 1. Well, then since log P goes to infinity, then you immediately can see that this is 2. I think that's it already. Question 16. A parabola and a circle. We have a parabola y is x squared and a point M, 0r, on the positive y-axis, and we look at the circle with center point M and radius r, and the origin is on the circle and also on the parabola, and dependent on r, the radius, you can either have a single common point or three. Then they ask us to calculate exactly for which values of r there are three common points or three intersections. Okay, well, let's write down the equation of the circle. The center point as x is 0, so you get just x squared and then plus y minus r squared equals r squared. So you can check the origin is on it. So substitute 0, 0, I can see that. And the other one to find the common points is y and x also have to satisfy this equation. So these are the two equations that need to be met. So we need to figure out for which r this has 1 and for which r this has 3 solutions. Okay, so the easiest way is to substitute the y in the expression for the circle. So I get x squared plus x squared minus r squared is r squared. And let's just work this out. X to the power 4 minus 2rx squared plus r squared has to be equal to r squared. Is this all correct? This looks good. So I get 1 minus 2r x squared, x to the power 4 is 0. I can factorize x squared, and let me write this first. It's 1 minus 2r, oops, is 0. So this is true when x squared is 0, or x squared equals 2r minus 1. So this one has the only solution x equals to 0, which we know is already like always a common point. So this gives, anyway, this is also not dependent of R, and this has a solution when 2r minus 1 is greater than 0, which means 2r is greater than 1, or r is greater than 1/2. Okay, I was wondering if this is correct, but this is 9/20. So 9/20 is less than 1/2. And for r is 1, we will see that we have 3 common points. Okay, so this is the answer then. Okay, last question 17. That's another omwentelingslichaam question. So we can put a line going through M. So M is the center of the circle, parallel to the x-axis, and you can define these two areas V and W, which you could rotate to get a volume. They also say that the rotation of a circle of this circle around the y-axis is a sphere with a volume given here. And we do the same with V and W. And then they say that the volume of rotating V and W, that there is a certain value of R for which these volumes are the same. And they ask us to find this value of R. Okay, well, let's find first the volume of rotating W, and that's, I guess, the reason why they tell us about the volume of a circle, because this will form half a sphere of radius R. As a matter of fact, this line here is the line y is equals to R. Alright, so this is simply 1/2 times the volume of the whole sphere. And this is 4/6, which is 2/3 pi r cubed. And what about volume of V? Well, that's the volume of the parabola being rotated minus the volume of that circle here. So this is the volume of the parabola, so Vp. And this we know already, so we just need to calculate Vp. So we can, let's do that, Vp. And for this we need to integrate all these x values here. Well, y goes from 0 to r. So it's 0 to r times pi. I need to multiply by pi. And then the value of x as function of y dy. Basically this each element here, pi times that x. Sorry, this has to be squared, x squared. Dy. This is basically a volume of a very small disk with a little bit like a coin, a thin coin with thickness dy. And we have to integrate this to get the total volume. But actually you don't need to necessarily understand this, you just follow what you have learned. I've seen last time, this is probably the third question I saw out of say nine exams now. So better learn this and learn this for two situations. One is for rotation around y, like done here. The other, a little bit more simple one, is for rotation around x. So what is that parabola? It was y equals x squared. That means that x, say if your x as function of y is the square root of y. You basically are just integrating the inverse function. Okay, so let's do that. I get this, and that's a simple integral. And simply 1/2 pi r squared. So that's Vp, so I have everything now. I have to set these equal. So uh, 1/2 pi r squared, that's this term, minus 2/3 pi r cubed has to be equal to 2/3 pi r cubed. So let's just combine equal or like terms. So I get r squared, bring this to the left, get a minus 4/3 pi r cubed equals 0. Now I just factorize pi r squared. Minus 4 over 3 r. Zero. Well, that happens if r is 0. I think we should exclude that. Did I say that somewhere? Of course, in that case, these volumes all become 0, so that's like a trivial case. I doubt that we need to consider that. Let's look at the more interesting case. Well, 1/2 minus 4 over 3 r is 0. That means 4 over 3 r is 1/2. Just multiply by the inverse, so we get r is 3 over 4 times 1/2 is 3 over 8. So, assuming we can exclude r is 0, then the answer is 3 over 8.